Hey everyone, it's Dan, the founder of DataInterview.com, ex-Google and PayPal data scientist. In this video, I'd like to cover 5 statistics concepts you definitely need to know in preparation for data science interviews. Now these topics are central tendency, dispersion, correlation, normal distribution, and hypothesis testing. Now this is a video if you are currently pursuing an entry-level data science position, or you might be already a data scientist and you simply want to brush up on basics of statistics. Now, before I start the video, I just want to say you definitely should check out DataInterview.com. It is an interview prep platform created by data scientists for data scientists. It contains courses and coaching services that can help accelerate your data science interview prep. So make sure you check out DataInterview.com. Now, without further ado, let's get started on the first topic, central tendency. In data science interviews, you might stumble upon a business case problem where you have to describe the shape of a distribution. And in order to describe the shape of the distribution, use something called central tendency. Central tendency describes where most of the data lies in the distribution. And you can use the following statistics as a way to describe the central tendency. It is mean, median, and mode. And the mean is the sum of values divided by the number of values. The median is a middle value in an ordered set. And the mode is the most frequent number. Now let's take a look at an example of how to calculate each of the 3 statistics. So the mean, you take the sum of the values divided by the number of values. And in this example, you see a set with 5 values, 1, 3, 4, 5, 5. So you take the sum of that, and then you divide it by the number of values in that set, which is going to be 5. And ultimately, the mean of this set X is going to be 3.6. What about the median? The median is the middle value in an ordered set. And in this case, the middle value is 4. So the median of this set X is going to be 4. And lastly, the mode is the most frequent number. And the most frequent number in the set is going to be 5 because it appears twice. And so the mode of this set X is going to be 5. Now, there are situations where you would want to use one over the other or a combination as a way to describe the central tendency. And in order to think about that, you have to think about the pros and cons of each of the 3 statistics. So starting with the first one, the mean. The benefit of using means is that it's utilizing all of the values. So it's using all of the information as a way to calculate what the central tendency is. But the consequence of doing this is that if there are outliers, so extreme values that are really far away from the typical range of where the values are, then the mean is very sensitive towards that. So that's something to be very mindful of whenever you're working with a data set with outliers or it is skewed in some ways. As a way to correct this, you could perhaps use median because a median is robust against outliers. But the consequence of using median is that it uses only one value. So unlike the mean where it uses using all of the information from the data set, the median is only using one value. So sometimes you don't have a good sense of what is the overall central tendency of a distribution. The mode is highly useful, especially when you're describing categorical variables. So trying to think about what is the frequency of certain value. But so similar to median, the downside of using the mode is that it's only using one value. Now let's take a look at example problems. A PM at Google asks you to describe the distribution of daily search queries per user. How would you describe it? When we take a look at the distribution below, we see that this is a normal distribution. It is centered at a particular value, and in this case, it is going to be 8, and it tapers off towards the extreme. And this distribution is symmetrical. So when we're describing this, we can say the following. The distribution of the daily search queries is normal with the mean at around 8, and the median and the mode are also at around 8. Let's take a look at another example. A PM at Meta asks you to describe the distribution of daily minutes spent on Facebook per user. How would you describe it? So when we take a look at this illustration, we see that it is skewed extremely. So it's actually truncated at 0. And then there's a peak somewhere around 0, somewhere around 1 to 5. And then eventually tapers off as the value of minutes increases. And so what this means is that the mean is going to be slightly higher than the median and the mode. So when we're describing this, we can say the following. The distribution of daily minutes spent on Facebook per user is exponential, with the mean somewhere between 6 and 5, and the median and the mode at around 8.2. The next topic I'd like to cover is dispersion. Dispersion describes the spread of data in a distribution. And you can use the following statistics as a way to describe the spread. And it is going to be variance. Variance is 1 divided by n representing the size of the data set, summation I equals 1 to the n, and the difference of xi minus x bar, which represents the mean of that data set, and this difference is squared. So basically what this means is that the further away values are from the mean, the higher the variance. Now I want to let you know that you definitely want to memorize this formula because you might stumble upon a business case problem or a coding round where you have to calculate the variance from scratch. And because this is an essential, a basic formula, it is really important that you have this retained in your head. Now, variance isn't the only way to explain the spread of the data set. You can also use standard deviation. Standard deviation is basically the square root of variance. And the square root essentially makes variance much more interpretable. The next topic I'd like to cover is correlation. Correlation describes the strength of linearity between two variables. And the correlation formula is the following. It is the summation of the difference between xi minus x bar times the difference of yi and y bar. And this is divided by the standard deviations of x and y, which are multiplied. And this particular correlation formula is something called Pearson correlation. And Pearson correlation consists of the following. It is basically the covariance on the numerator of this fraction, and then the standard deviation on the bottom. And basically what the standard deviation does is it's going to scale the covariance in a range of -1 to 1.0. And this makes the correlation value much more interpretable. So when you're trying to interpret the correlation, you can use the following guidance. So here's an example. Suppose that the correlation of two variables x and y are 0.9. And because it falls within the range of 1.0 and 0.8, what that means is that the correlation is going to be strongly positive. Another example is where if the correlation value is just 0, then that means that there's no association between the two. But what does this look like visually? Let's take a look at a couple illustrations. So here's an example where you have x and y. And you can see that there's a positive linear trend between the two. As x is increasing, y is increasing as well. So the exact correlation value is 0.9, which means that it is strongly positive. Let's take a look at another example. In this case, we see that there's a flat line. As x is increasing, y just remains fairly constant. And because of that, the correlation value is going to be 0.0, which means that there's no association between the two. Here's a third example. The third example in this case is basically a negative trend. As x is increasing, y is decreasing. So what this means is that the correlation value is going to be minus 0.9 with a strongly negative interpretation. And here's the last example. In this case, generally speaking, it seems like there's a positive direction, but the data points are somewhat dispersed. So even though it is positive, it's going to be weakly positive, and it's reflected by the correlation value being only 0.1. So here's an example problem. A data scientist manager at Google asks you, how would you measure correlation in the presence of outliers? How would you address this question? So when you take a look at this example, you see the presence of outliers represented by this red circle. You can see that while the typical values of where most of the data lies are somewhere between negative 7.5 and 5.0, the y on the other hand is somewhere between 7 and 13. But then we see these three outlier data points, which are fairly farther away from where most of the data lies. They're much more in the extreme ends of where the x is, somewhere between 8 and 12.5. So how do we go about interpreting this, and along with what is a potential solution to correct for this procedure? So our initial analysis is that outliers can either deflate or inflate the correlation. And in this case, and what is going to happen is that because we have these outliers which are extreme on the x but fairly low on the y, the linearity is going to be somewhat deflated because of the presence of the outliers. And so ultimately, the correlation value is going to be deflated to an extent. And the solution for that is using either an IQR method, which will help remove the outliers, or scale it using standard normal scaling or normal or robust scaling. The next topic I'd like to cover is normal distribution. This is perhaps the most famous distribution there is. The normal distribution is characterized by symmetrical shape around the center, and the extremes are tapered off. And the probability density function of the normal distribution is the 1 divided by sigma square root of 2 pi e raised to the power of minus 1 over 2 times the x minus mu divided by sigma, and this fraction is squared. When you talk about normal distribution, you definitely want to talk about the 66, 95, 99.7 rule. And what this basically represents is the percent of data that falls within the normal distribution within certain standard deviation. 66 represents the 66% of data falls within 1 standard deviation from the mean. 95 is 2 standard deviation, 99.7 is 3 standard deviation. I would highly recommend that you memorize this because this information is going to be important when you're calculating confidence interval from scratch. And there are going to be some situations where you have to do this in a statistics interview of data science. Now, the next topic to know is central limit theorem. It basically means that a distribution of sample means approximates a normal distribution as the sample gets larger, regardless of the population distribution. So let's actually break this down. So what this means is that it really doesn't matter what the underlying distribution is from the get-go, whether it is uniform, exponential, or chi-squared. If you just keep taking a sample of this, and per sample, the size is large, so let's just say 10,000. What this means is that as you plot this sample mean in a histogram, it is going to look like a normal distribution. So this is important because there are going to be some case exercises where you have to understand the central limit theorem as a way to solve this. And I've created a video about this before based on a meta statistics interview question. And I'll post a link here so you can follow up on that video. The last concept I'm going to talk about is hypothesis testing. This is one important concept to know in preparation for data science interview. I would expect it to be a fair game if you were asked to calculate hypothesis testing from scratch. So I would definitely brush up on this concept. Now let's start with the business case problem. Suppose that a PM claims that users on average spend about $50 per month on Amazon. However, you doubt this claim and you believe that the average should be higher. So you sample 100 users and learn that the sample mean is $85. Would you reject the PM's claim? In order to solve this problem, we can think about it statistically, basically in the form of hypothesis testing. Hypothesis testing is the following. It is a way to test an assumption about a population parameter. When you're setting up the hypothesis testing, there are 4 steps in this procedure. There's the hypothesis test, sample data, statistical test, and statistical decision. What are those? The hypothesis is basically you're stating what the null hypothesis, what's the baseline claim, and it's indicated by H naught. And alternative hypothesis, basically this is a claim that's repudiating the alternative hypothesis, and it is represented by H naught. Once you set up the hypothesis testing, you basically take a sample from population, and you calculate the statistical formula to calculate the p-value. The probability of observing sample value given that the null hypothesis is assumed to be true. Don't worry too much about what this actually means. We're going to go over this. And lastly, you essentially make a decision. So based on something called p-value and significance level, if the p-value is less than the significance level, which is denoted by alpha, then you reject the null hypothesis. Otherwise, you fail to reject the null hypothesis. Now let's start by calculating the p-value. Now, what is p-value? P-value is a probability of observing a sample value or more extreme given that the null hypothesis is assumed to be true. So what this means is that we start with the null distribution, with the population mean being 50. And we want to calculate the probability of observing the sample value, in this case, which is going to be 85, or more extreme, under this null distribution curve. And so when we want to calculate the p-value, we have to use something called z-statistics. And the z-statistics is basically a way to standardize the sample mean in a standard normal distribution where the mean is equal to 0 and the standard deviation is equal to 1. And once we have the z-statistics, then we need to calculate p-value. And in order to calculate the p-value, we use something called this standard normal distribution table. And I'll talk a little bit more about how do you actually interpret this so you can compute what the p-value is. And there are, of course, other tools that you can use. You can use stats models, which is a third-party library in Python, or there are some free web applications that can help you calculate the p-value. Now, when you calculate these z-statistics, then ultimately using that table, you can calculate the p-value. And from there, you compare this probability of observing this x equals 85 or more extreme against the decision threshold, or significance level, denoted by alpha. And so what is significance level? Significance level is the probability of rejecting the null hypothesis assumed to be true. And this is under the standard normal distribution, where we know that the sample mean, where we know that the population mean is 0 and the standard deviation is 1. And so typically we set the significance level, or alpha, as 0.05. And there are cases when you want to increase the alpha or decrease the alpha, depending on what is the type 1 error rate you're willing to accept, because alpha is equal to type 1 error rate. And how do we interpret the alpha? So alpha being 0.05 basically means that there's 5% chance of rejecting a null hypothesis when assumed to be true. So what this means is that if we were to run a simulation with 100 statistical tests, or hypothesis testing, then about 5% of them is going to reject the null hypothesis. And so we compare this alpha against p-value. And we reject the null hypothesis if the p-value is less than alpha. And we say that there is statistical significance to reject the null hypothesis and accept the alternative hypothesis. But if the p-value is greater or equal to alpha, then we fail to reject the null hypothesis. So let's go back to this business case problem. And in order to solve this problem, we need something called the population standard deviation in order to calculate the z-statistic. So for the sake of this exercise, let's assume that the population standard deviation is 20. So the first thing we need to do is state the hypothesis statement, which is the H0, basically meaning the average spend per user is $50, and H8, which means that the average spend per user is greater than 50. And we set the significance level from the get-go. And in this case, we're going to set the alpha as 0.05, which is typically a bit of an industry standard value when it comes to experimentations. Now, we want to calculate the test statistic. And in this case, in order to calculate the z-statistic, we plug in the following values. So 85 is equal to the sample mean, x bar, and the mu is equal to 50, and the standard deviation is equal to 20, and this is divided by the square root of n, where n is equal to 100. When we simplify this, this is going to be 35 divided by 2, which is going to be 17.5. Now the next step is to calculate the p-value. In order to calculate the p-value, we need to go back to this standard normal distribution table, or z-score table. And essentially, in order to calculate the z-statistic, we have to start with the z-score value. And we know that the z-score value is going to be 17.5. And because 17.5 is greater than 3.9, obviously the p-value is going to be much smaller than this value. So I calculated the p-value by using a web application. And so the p-value is less than 0.0001, which is less than alpha, where alpha is equal to 0.05. So we can have the following conclusion. Basically, at alpha equals 0.05, there is statistical significance to reject the PM's claim and conclude that the average spend per user is greater than $50. So there you have it, guys. Here are the 5 statistical concepts you need to know in preparation for data science interviews. Now, I just want to let you know, obviously these 5 concepts don't cover all of the aspects that you need to know in preparation for data science interviews. So I laid out a couple concepts you should definitely review. These are distributions, Bayes' theorem, ANOVA, sampling, non-parametric tests, permutation tests, confidence and credible intervals, regression modeling, non-normal distribution, and maximum likelihood. Now in future videos and also the statistics course, which I'll plan to launch in the coming weeks, we'll cover these statistical concepts. So definitely stay tuned. Now I hope you enjoyed this video. Definitely stay tuned for more videos like this. I'll see you in the next one. Bye.